Alright, now let's take a look at a proof that involves trying to prove lines parallel. So we look at this case. Now I'm trying to prove TA is parallel to SR, which means I have to find one of those things we talked about. If I could show corresponding angles congruent, the lines have to be parallel. If I could show that I have a pair of alternate interior angles congruent, the lines have to be parallel. If I could show I have a pair of same side interior angles supplementary, the lines have to be parallel. Two other specialty cases there. We talked about 5 ways to prove lines parallel. The other one was 2 lines perpendicular to the same line have to be parallel to one another, and 2 lines parallel to the same line have to be parallel to each other. So in this case, the one thing I like to do when we're trying to prove lines parallel is the first thing, highlight the lines that you're trying to show parallel. So in this case, I'd bring in a highlighter. I'd be like, all right. And then I would say, all right, can I now look at making one of those shapes? Can I make a C? Well, I could make a C there and a C there. That might not help me. Can I make the Z? Well, I got a pair of alternate interior angles, so I can come up here and be like, and when I look at that, it's be like something should be jumping out at you right now. You know, again, alternate interior angles makes the Z. Corresponding angles make the F. Same side interior angles make the C shape. So we're looking at one of those things. So since I have that Z shape going on, if I could now show that 2 equals 3, that's a pair of alternate interior angles. If I get them equal, then I've got a pair of alternate interior angles congruent, which would mean these lines have to be parallel. That was one of the theorems we talked about. So we look at starting off with a given. Now again, I wanted to show 2 equals 3. I got half of it right there. There's the 2. Can I turn the 4 into a 3? So we start off with a given. Segment SA bisects angle TAR. Again, as you write that down, segment SA bisects angle TAR. As soon as you write bisects down in your head, you should be like, whenever you see a word that we've defined, 95% of the time we're using the definition of that term over here to give us a statement. So then I would ask you, what does an angle bisector do? If this bisects angle TAR, which is this big angle up here, it divides the angle into 2 congruent parts. Those 2 congruent parts, 3 and 4. Now I already know from the given 2 equals 3, so I could have marked that off. Now by the definition of angle bisector, angle 3 equals angle 4. Two equals 4, 3 equals 4. What do you think I'm doing with 2 equations? If this equals 4 and this equals 4, I can substitute in there. Angle 2 equals angle 3. We just used substitution property. Now, what did we just show? We just showed 2 equals 3. What kind of angles are 2 and 3? It makes the Z. They're alternate interior. So now I've got a pair of alternate interior angles that we just showed are equal. What can I now say is true about these lines? Segment TA is parallel to segment SR, and the reason is going to be alternate interior angles congruent gives me parallel lines. Again, whatever's right here, whether it's corresponding angles congruent, same thing, whatever's here has to be what I just showed. And that's the reason I get a set of parallel lines. So let me come up with one more. We'll take a look at one maybe a little harder that involves a few other things.